Okay, hi again. We continue the second session of structure and function of lipids with discussion about sphingolipids. Here you can see the structure of the ceramide, which ceramide composed from sphingosine and fatty acid. Uh, If the phosphocholine attached to this group, the sphingomyelin is produced. Phosphocholine attached to the ceramide, sphingomyelin is produced. The non-phosphorylated lipids or glycosphingolipid or glycolipids are seen widely in nervous tissue. This group of lipids do not contain phosphoric acid. Instead, they uh, they contain carbohydrate and ceramide. And ceramide plus glucose produce a glucocerebroside, and ceramide plus galactose produce galactocerebroside. And you can see here a glucocerebroside, which glucose attached to the ceramide. And the globoside, other type of glycosphingolipid, contain D3 or tetrasaccharide, like glucose and galactose. And also the gangliosides have at least one molecule of neuraminic acid or N-acetylneuraminic acid. As you can see here, neuraminic acid, the other name of neuraminic acid is salicylic acid, sialic acid, sorry. If neuraminic acid attached to this type of carbohydrate and ceramide, the ganglioside is produced. Ganglioside contribute to stability of junction and ion channel cluster in myelinated nerve fibers. And autoantibodies to GM1 disrupt lipid raft and ion channel cluster in peripheral motor nerves. Sulfolipid or sulfated, these are formed when sulfate group are attached to the ceramide oligosaccharide. All these complex lipids are important components of membrane of nervous tissue, and failure of degradation of this compound result in accumulation of this complex lipid in central nerve system, and this group of inborn error is known as lipid storage disease, or other name is sphingolipidus disease, which you will learn them in lipid metabolism in next semester. Okay, again, you can see the structure of different type of glycosphingolipid. The ceramide and galactose produce the galactocerebroside, and you can see the structure of our antigen blood group: O antigen, A antigen, and B antigen. They have a simple monosaccharide in addition to the backbone of this carbohydrate chain. For A antigen, we have a N-acetylgalactosamine. For B antigen, we have a galactose, and for AB antigen, we have both of them. So, until here, we learned different type of lipids. Storage lipids or neutral lipid, just we have a triacylglycerol, which composed from glycerol and 3 fatty acid. And other type of lipids are membrane lipids or polar lipids, which they divided to two group phospholipids and glycolipids. Phospholipid also divided to glycerophospholipids and sphingolipids. The glycerophospholipids contain the alcohol, glycerol, and sphingolipid have a sphingosine alcohol. And glycolipids also divided to sphingolipid and galactolipid or sulfolipids. Both they have the sphingolipids have a sphingosine, and galactolipids can have a glycerol or sphingosine also. In addition, they have mono or the oligosaccharide, and galactolipids also have a sulfate group. Icosanoid. Icosanoid, this compound derived from icosa or 20 carbon polyenoic fatty acid. Comprise the prostanoids, leukotriene, and lipoxin. Prostanoid also include prostaglandin, prostacyclin, and thromboxane. Prostaglandin exists in virtually every mammalian tissue, acting as a local hormone, and they have an important physiologic and pharmacologic activity. They are synthesized in vivo by cyclization of the center of carbon chain of 20 carbon or icosanoic. Uh, A related series of compound thromboxane have a cyclopentan ring interrupted with an oxygen atom or oxygen ring. These different icosanoid fatty acids give rise to three groups of icosanoid characterized by the number of double bond in the side chain. For example, prostaglandin 1, prostaglandin 2, and prostaglandin 3. Different substituent group attached to the ring give rise to series of prostaglandin and thromboxane, labeled A, B, and etc. Okay, you can see here different type of icosanoid like prostaglandin E2, prostaglandin F2 alpha, and prostaglandin I2. Also, you can see thromboxane A2 and leukotriene A4. The leukotriene and lipoxin are a third group of icosanoid derivatives formed via the lipooxygenase pathway. They are characterized by the presence of 3 or 4 conjugated double bonds. Leukotriene cause bronchoconstriction as well as being a potent pro-inflammatory agent and play a part in asthma. Here you can see the position of action of different type of phospholipase. Here we have a phosphatidyl inositol, and we have 4 type of phospholipase: A1, A2, C, and D. Phospholipase A1 cleave this fatty acid in carbon number 1, and phospholipase A2 cleave this bond between carbon number 2 and fatty acid, and phospholipase C cleave the bond between phosphate group and carbon number 3, and also phospholipase D cleave after the phosphate group. And you can see the phospholipase A1 and A2 produce a lysophospholipid, and phospholipase C produce a phosphatidic acid plus alcohol group, and phospholipase C produce diacylglycerol and phosphoalcohol, and phospholipase D produce the phosphatidic acid plus alcohol. Uh, Arachidonic acid is a precursor of all of eicosanoid. As you can see here, the phospholipase produce arachidonic acid from phospholipid and it's cleave on carbon number 2 of phospholipid in membrane, and arachidonic acid is released. After that, arachidonic acid can go through the two pathway, a lipooxygenase pathway and cyclooxygenase pathway, or LOX and COX. The COX pathway or cyclooxygenase pathway produce the prostaglandin and thromboxane, which non-steroid anti-inflammatory drugs inhibit this enzyme and prevent from inflammation and also from thrombosis. Because prostaglandin are important for inflammation and vasodilation, and thromboxane are important in hemostasis. Other pathway for arachidonic acid is lipooxygenase. Lipooxygenase produce lipoxin and leukotriene. Lipoxin also act as an anti-inflammatory factor, and leukotriene are important in vascular permeability, neutrophil and eosinophil recruitment. Okay, all type of eicosanoid are important in different pathway in our body, and a lot of drug are produced to prevent from producing these compound in our body for preventing inflammation, fever, thrombose, and other uh, physiologic and pathologic situation. Steroids play many physiologically important roles in our body. Although cholesterol is probably best known by most people for its association with atherosclerosis and heart disease, it has many essential roles in our body. The word cholesterol is derived from Greek words chole mean bile, estro mean solid, and ol mean alcohol. Almost all nucleated cells, including arterial wall, can synthesize cholesterol. It is widely distributed in the body in 70 kilograms man. A total of about 140 gram of cholesterol is available, which is distributed as about 30 gram in brain and nerves, 30 gram in muscle, 30 gram in adipose tissue, 20 gram in skin, 10 gram in blood, also 10 gram in liver and spleen, and 5 gram in bone marrow, and also 2 gram in adrenal gland. Cholesterol is light yellow crystalline solid. When the crystals are examined under the microscope, they show a notched appearance. Cholesterol is soluble in chloroform and other fat solvent. It is the most important animal steroid from which other steroid components are formed. Also, cholesterol is widely distributed in animal tissue. It is absent in prokaryotes. In plant, cholesterol is absent, but other plant esterol are present, or other type of esterol is present in plant. In bacteria and plant, compounds similar to steroid exist, known as a hopanoid. Cholesterol was isolated from a gallstone by in 1758, and cholesterol characterized in 18th century. Complete structure of cholesterol was introduced in 1918, which who got Nobel Prize in 1927. As I mentioned, cholesterol is a precursor of large number of important steroids such as the bile acid and other steroid hormones, sex hormone, vitamin D, and cardiac glycosides. All steroids have a similar cyclic nucleus resembling a phenanthrene, rings A, B, and C, to which a cyclopentan ring D is attached. Here you can see the main structure of steroid and also cholesterol. All steroids have a cyclopentano perhydrophenanthrene. As you can see here, cyclopentano perhydrophenanthrene ring system. It is a fused ring system made of three cyclohexane rings designated as A, B, and C, and a cyclopentan ring D. The six-membered ring are in phenanthrene arrangement. Total 27 carbon atoms is present in cholesterol structure, and one hydroxyl group at third position, which is characteristic of all esters. The OH group is beta oriented and projecting above the plane of ring. And the other characteristic of the ester is there is a double bond between carbon atom number 5 and carbon atom number 6, as you can see here. And also there is a 8 carbon beta orientated side chain attached to the carbon number 17. So the main properties of the cholesterol is composed from 4 rings, the phenanthrene and cyclopentan, which there is a double bond between carbon number 5 and 6, and OH group in carbon number 3, and also the hydrocarbon tail attached to the carbon number 17, which composed from 8 carbon, and also the total carbon of cholesterol is 27. And here, this ring system are steroid nucleus. And the cholesterol ester, in addition to cholesterol structure, have another fatty acid attached to the OH group on carbon number 3. So, free cholesterol uh, free cholesterol is not attached to the fatty acid, but cholesterol ester is attached to the fatty acid. Here in this table, you can see the functions of cholesterol. Cholesterol are important in cell membrane, and cholesterol is a component of membrane and has a modulating effect on fluid state of the membrane. And also, cholesterol is used to insulate nerve fibers and act as a nerve conduction. Also, the cholesterol is used to produce the bile acid and bile salt. Both are derived from cholesterol. Bile salt are important for fat absorption. And steroid hormones such as the glucocorticoid, androgens, and estrogens are formed from cholesterol. In addition to steroid hormone and bile salt and bile acid, also vitamin D is formed from 7-dehydrocholesterol. And the other property of cholesterol is esterification. As I mentioned, the OH group of cholesterol is esterified to fatty acid to form cholesterol esters. This esterification occurs in the body by transfer of polyunsaturated fatty acid by lecithin cholesterol acid transferase, or LCAT in brief. Here you can see different type of steroid hormone like testosterone, estradiol, cortisol, aldosterone, and other type of hormone. All of them have this ring system which composed from 4 ring, 3 or phenanthrene here, and the cyclopentan. But they have a different with cholesterol. As you can see here, the OH group changed to the ketone group or hydroxyl group in estradiol, and also the hydrocarbon tail there isn't in steroid hormone. And carbon number in testosterone, cortisol, estradiol, and aldosterone is different. Cholesterol is a significant constituent of many tissue and widely distributed in all cells of the body, and especially in nervous tissue. It is major constituent of the plasma membrane and the plasma lipoprotein, and also it's often found in cholesterol ester, where the hydroxyl group on position 3 is esterified with long-chain fatty acid. It occurs in animal but not in plant or bacteria, and ergosterol occurs in plant and yeast, and it's important as a dietary source of vitamin D. Polypenoids share the same parent compound as a cholesterol, like ubiquinone and the liquor. Amphipatic lipids. Formation of lipid membrane, micelles, emulsion, and liposomes are liposomes from amphipatic lipids. Phospholipids in general are amphipatic, especially lecithin. Phospholipids have both a hydrophobic and hydrophilic portion in their molecule structure, and the glycerol along with the phosphoric acid and choline, constitute the polar head of the phospholipid molecule, whereas the hydrocarbon chain of the fatty acid represent the nonpolar tail. Micellar formation is happen when a phospholipid are distributed in water. Their hydrophobic parts keep away from water, forming molecular aggregate called micelles. These are involved in solubilization of lipid in aqueous media and help in digestion and absorption of lipids. Other type of these special lipids are liposomes. Liposomes are a lipid bilayer will close on itself under appropriate condition, and a unilamellar or multilamellar liposome may be formed. They may be prepared by sonication of mixture of phospholipid and cholesterol. Liposomes are microscopic spherical vesicle, and when they mixed in water under special condition, the phospholipid arrange themselves to form a bilayer membrane which includes some of water in phospholipid sphere. A different type of substance like drug, protein, enzyme, genes, etc. may be encapsulated by liposome, which could act as a carrier for these substances to target a specific organ. Liposomes entrapped drug exhibit a superior pharmacological properties. And liposomes have important application in cancer chemotherapy, antimicrobial therapy, gene therapy, vaccines, and diagnostic imaging.